Hello, this is Miss Salter, and this video is to review the practice problems from the statics unit. Practice problems number 1. So, number 1, what is the magnitude of the electric field intensity at a point in the field where an electron experiences a 2.4 Newton force and electrons have a charge of negative 1.6 times 10 to the negative 19th coulombs? Okay, so electrons and protons both have the same size charge, 1.6 times 10 to the negative 19th. It just depends on whether they're positive or negative, depends on, whether it's an electron or it's a proton. It's called an elementary charge. So we're looking for an electric field intensity, so that would be E. We have a force of 2.4 newtons, and we have a charge. And so therefore we're going to use E equals F divided by Q, and we solve and we get 1.5 times 10 to the 19 newtons per coulomb. Since we are just finding the magnitude of the electric field intensity, we don't need to worry about whether the charge is positive or negative. It's just a charge. Okay? Same thing with number 2, magnitude of electric force acting on an electron. Locate an electric field with an intensity of 8.6 times 10 to the 3rd newtons per coulomb. Same thing, we're working with an electron here. And so we just changed around that equation to solve for F. So F equals E times Q. And that should have a newtons label on it. F equals 1.376 times 10 to the negative 15th. Number 3, if our point charge has, so we're not talking about an electron or a proton here, we're just talking about a charge in as a point. What is the magnitude of the electron force acting on that charge in an electric field with an intensity of 3.6 times 10 to the 3rd? So here we're looking for the F, but we're using something other than an electron because we have just a particle making a charge. And therefore our answer is 1.84 times 10 to the negative 15th newtons. You just have to be careful with the scientific notation again. So you got to make sure that if you're using a regular calculator, you use your parentheses. All right, Joanne rubbed a balloon with wool to give it a charge of negative 1 times 10 to the negative 6 coulombs. Because when you rub a balloon with wool, you are frictioning off some of the electrons and transferring them from one substance to the other. She then acquires a plastic golf tube with a charge of 4, so it's positive, localized at a given position. So it means that part of the golf tube has a positive charge. She holds the location of that charge on the plastic golf tube a distance 50 centimeters above the balloon. Determine the electrical attraction between the golf tube and the balloon. So she's got a balloon which has been negatively charged by rubbing it with the wool. The electrons have moved to the balloon. Then she has a plastic tube, and part of it is positive. And she wants to know, okay, what is the attractive force between these two things, the positive end of the tube and the balloon? So we're determining the attractive force, the Fe, electrical force of attraction. Now, K is just like big G when we were doing law of gravitation. It's just a constant. It has to do with the charges and their relationship to the air around them. K would be different if you were working in a vacuum or if you were working underwater. We're just working in the air. You take and you multiply that K value times your two Q values. and then you divide that by r squared. So you had to change the r from centimeters to meters, and you have to remember to square it. Otherwise, you don't get the right answer. The answer is 0.144 newtons. Okay? Number 5, a balloon with a charge of 4 times 10 to the negative 6 coulombs is held a distance 7 meters from a second balloon having the same charge. We're looking at the magnitude of the repulsive force. They're both negative, so therefore they're trying to push each other away. So we have, and basically when it's the positive or the negative on the force, that's telling you whether it's attractive or repulsive. We're just looking for the magnitude. So just the sheer size of the force. Don't forget to square the r on the bottom. Answer is 0.294 newtons. Number 6. At what distance is of separation must 1 times 10 to the negative 6 coulomb charges be positioned in order for the repulsive force between them to be equivalent to the weight on Earth of a 1 kilogram mass? Weight equals mg. Okay. So weight equals mg, that's a force. So if we take, and so that means that the force, the electric force here, the repulsive force needs to be equal to that weight, Fg. So we just set them equal to each other. The weight of 1 kilogram mass is 1 times 9.8 times 1.1 kilogram times 9.8 meters per second squared. So it would be 9.8 newtons equals, and then your Coulomb's law, K times the two charges over our R value. So you're setting everything equal to R. So you see here, I just left it as R squared to begin with. Then I switched, put the R on its own side, brought the 9.8 over by dividing. 1 times 10 to the negative 6 times 1 times 10 to the negative 6 is 1 times 10 to the negative 12. And then you multiply that by the constant, and you divide, and then you need to do the square root. Have to do the square root, and then you get, the distance is 0.0303 meters, which actually would be equal to 3 centimeters. And lastly, sphere with a charge of plus 3 microcoulombs. Microcoulombs was in the notes. It just means coulombs times 10 to the negative 6th. So it's 3.6 times 10 to the negative 6 coulombs. That sphere is a certain number of meters away from, that's a positive, away from a sphere with a negative charge, causing a force of 3 newtons. So we have a charge on one sphere, we have a distance, we have a force. Well, we have a second sphere. So the charge on the second sphere would then be Q2. So we solve for Q2. Force equals, in this one, what I did was I multiplied my K value times Q1 first, and then got this 32,400. Then did the division, then divided it to the other side, and then changed it into scientific notation so it was a little bit easier to understand. And the answer is 1.3 times 10 to the negative 3rd. And that would be, and of course it says what's charge is the negative, so it would be a negative. But that is the magnitude of my charge. 1.3 times 10 to the negative third. Okay? So hopefully these guys were helpful. They were based on model problems from the notes. So so now you should have probably at least 2 problems of every one of these types to look at. So I hope this is helpful, and have a good day.